Hi, welcome again. So, in the part one of what is machine learning, we generally try to understand at a very high level the promise that this field has in the next decade or so, and the kind of careers people can make, and sheer happiness people can get getting involved in these kind of new technology areas. So, in this lesson, I'm going to focus on practical versus academic machine learning, because as you are trying to learn better, actually get a good orientation on which way to learn this machine learning course. Because when I wanted to learn myself, I felt this is very important, as in the beginning itself, to understand which course to take as you learn this topic called machine learning. So So I've been talking to a lot of youngsters and a lot of my colleagues in the software testing community, and generally asking, because we all wanted to learn. And uh, maybe my question to you as a learner: have you ever thought like this about learning machine learning? So some people told me maybe I'm not good enough at math to learn machine learning. Maybe I have to start with maths, and really I'm not able to make any progress because I forgot about maths that I studied in engineering. So this is the very fundamental kind of reaction I have seen from my colleagues. And sometimes people told maybe I need to go back to grad school to learn this stuff, and maybe that is why I have to pay a lot of money to learn this course. And some people also felt that it will take me years to master everything. Maybe I should pick a different field instead, and they left. In fact, I too have felt the same way when I wanted to really learn what is this topic all about, and how do I apply this knowledge into my software testing domain. So that is the primary purpose with which I started learning. So these are the questions people are asking, and if you also have felt that way, don't blame yourself. And why everyone is kind of tending to think this way? Because most of the courses out there, they are way too obsessed with individual algorithms. I opened a lot of these syllabus documents or curriculum details of these so-called elite programs, and I found a lot of Greek and Latin for me, for at least about the details of algorithms and algorithms and algorithms. So generally, the academic way people are taking, and the academic way is more kind of bottom up approach to machine learning. And actually, they're placing a lot of emphasis on math and theory at the beginning. I'm not telling that you should not have conceptual understanding of maths and theory. It is required, but at the beginning, it can kind of uh, demotivate you. That's why don't start there. And also, this academic kind of machine learning programs, they try to teach you the details of each algorithm, but not how to apply them effectively. So I have seen a lot of online courses, as well as the instructor led trainings and the curriculum. They are focusing too much things on how to build algorithms from scratch. Maybe that is required, but not for a applied machine learning context. And while there is nothing wrong with learning about different algorithms, absolutely there is nothing wrong, but spending so much time on them at the start can cause a lot of students to miss the forest for the trees. So please keep it in mind. That's why I raised this point very early in our course, that the contrasting between an academic machine learning course versus a practical applied machine learning course. So practical versus academic machine learning. So we typically use practical machine learning courses that are applicable for the industry, and they are very different from academic machine learning courses that are taught in schools and graduate colleges. So typically, academic machine learning focuses on math and theory. Sometimes, though we studied this maths as engineering graduates, while we were in college, but right now when we see this kind of equations and all, some dizziness comes. But they're not that complex. Keep that in mind. But academic this academic machine learning courses, they are trying to do that. So practical machine learning courses, they focus on intuition and simplicity. So they reduce some of these complexities of understanding maths to start with, understanding what at a broad level an algorithm does. So that is why always start to learn in a more practical machine learning point of view rather than academic, especially when you are out of college and you are very busy, engaged in a lot of your project work, but at the same time you wanted to really dirty your hands and create good understanding of this new field. Then better you start with practical machine learning courses rather than academic machine learning courses. So again, to repeat what I said, practical machine learning focuses on intuition and simplicity with a strong emphasis on results. They try to solve real world problems and they deliver value. And again, it encourages efficient prototyping instead of deep research. So, to start with, these are all very important. Whereas the academic machine learning, they focus on a lot of cutting edge original algorithms. So, if you want to really develop them, then if you want to work in research areas, then yes, you have to learn that way. Maybe go to a grad school, pay decent fees for that and learn in a very systematic way, because that is very much needed. And if you want to really write highly optimized algorithms from scratch for very advanced problems, solving very advanced problems, then yes, it is the right way of learning. So in this particular part 2 of my lesson, I wanted to really orient you that don't get confused with all the great things people talk about machine learning from an academic point of view, and don't please get demotivated. It is fairly easy, and we will take more practical point of view of machine learning and learn. That is going to be the way that we will do it in this course. So learn and have fun.